Hello, everybody. Thank you once again for joining this webinar, this net automation crash course that we are doing in between Cisco DevNet and the Nairobi DevOps Community. If you were not here on the first session, let me reintroduce myself to all of you. My name is Alfonso. Please call me Poncho. I'm a developer advocate at Cisco DevNet. And just to refresh your memory, what we explored on the last session was basically how to create your own templates for CLI commands, for CLI configurations. And also we checked how to collaborate with all your fellow colleagues using Git for creating your templates and to treat it as your single source of truth. So today we're going to crank up the volume a little bit, and we will wrap up with this topic, but also we will jump into real device interaction using programmability tools. So if that sounds interesting, please stick around. And without further ado, please allow me to share my screen, and let's see how this goes. Okay. Just give me 1 second. There we go. Okay. And if you could tell me if you can see my screen, please, that would be fantastic. I'm reading you here in the chat. If somebody could confirm that you can see my Visual Studio, that would be fantastic. Okay, cool. That's great. Awesome. Okay, so just to recap a little bit. Oh, well, before starting, same rules as on the last session. Whenever you feel like asking something, whatever that may be, please ping me. I'm having a look here on my other screen at the chat. You can raise your hand, whatever it takes for me to dry stop and answer your question on the spot. Okay, I want this to be interactive. I want this to be as useful as possible for all of you. Okay, perfect. So let's talk about something that you are going to be finding very, very often out there in the wild in production. And it all starts with this premise. Not everything in life comes on a spreadsheet format, unfortunately. We used the CSV file before for illustrating how data comes, the data about your new branches, your routers, your switches, whatever. But unfortunately, it won't be that pretty more than often. More and more devices, more and more environments talk other data formats, and it's very important for all of you to be aware of those. And in this session, I'm going to mention very, very briefly two specific data formats. You may have heard about them already. I'm just going to touch like the surface, but it's for all of you who don't know about them. I want you to be certain that this is happening out there. The first one is JSON. JSON is JavaScript-oriented notation. This is a format that you will find more than often in applications. When you connect to other services, JSON is a very, very popular, very widely spread format for representing data. So, for example, I can give you an example on top of my mind. If you are using a device management system, like an inventory system, like Netbox, for example, that is super popular, when you download the data, when you do like a backup of any sort, you will find the information of your devices in JSON format. It's very simple to read. It's very, very simple to understand. Basically, we have opening and closing brackets to represent an object. And each of these objects will have parameters within. It will have attributes within. It can be, for example, in this case, the whole thing can be a device, right? So it can have like a branch host name, branch IP, subnet, one IP, whatever. And you can see here that it's what we call key and value. Key and value, key and value. That means the keys will always be in between the quotes. Then we have semicolon, and then we have the values, right? These values could be at the same time other JSON objects. It could be like a JSON within a JSON within a JSON. That can happen, okay? So long story short, open brackets, closing brackets, key, value, key, value, key, value, and all these keys are going to be in between quotes, okay? Easy peasy, nothing too fancy here going on. Then another format that you will find this mostly in legacy systems, but it's still it's still very used. This is XML, which is extensible markup language. This format, it's you have here this structure. You may have seen it before, especially for those here who work with like pure networking. That if you have worked with programmability protocols like netconf, this is the de facto data structure for netconf, right? We'll talk about netconf later in this course, but for now, just stick to me with this. We have tags. XML is all about the tags. We have an opening tag and a closing tag. And this represents an object, an entity, whatever you like. In this case, it can be a device. So it's opening tag, device, closing tag. We have there the hyphen and then the word, right? So it's here. Device, it opens, device, it closes. And the same logic applies for the attributes that are within. So we have here the branch host name, it opens and it closes. Branch IP, it opens and it closes. Branch subnet, it opens and it closes. And we have the real information in between these two. So again, this is just the tip of the iceberg, right? It's for you to be aware of JSON and XML. Now, what happens when we're working with these data types? So let's go back to the exercise that we did on the first session, sorry. And you remember that we were working on a script for parsing our CSV data of the devices into the templates that we used with Jinja. You remember that we created this beautiful golden template that is versioned there on GitHub, and we're taking all those placeholders and replacing the values again and again and again using the CSV information. Well, now let's revamp this a little bit. Let's make it more usable and actually support both JSON and XML inventories. So what I want to do is to be able to create my templates using these inventories. This .json that you can see here, we have a list of JSON objects. You can see here that it's opening bracket, closing bracket, which means a collection of things. And then each of these things is going to be a JSON object. You can see it here. It opens, it closes. So this is device 1, this is device 2, this is device 3, and so on, and so on, and so on. But also we want to support an XML inventory. You can see it here that we have an inventory object. It opens and it closes, right? Inventory, opening and closing. Cool. And then here we have several devices. You can see here when I collapse them that they open and they close. They open and they close and so on and so on and so on. And here we have all the different attributes of each device, okay? So we want our Jinja script, our script that renders a Jinja template to support this and to support that, this and that, and also the CSV file, okay? We want to support the three of them. Let me give you an idea of how to do that very quickly, very briefly. So let's go back here. What we are going to do, you remember ARG Parse, right? Like this nice Python library for making our scripts more like tools, for making them more usable, for making them more, that we can have like inline options, we can change how they behave and make the lives of the people who are going to use them way easier, way nicer, right? You remember that we used ARG Parse library? Well, now we're going to be adding some different options to our script using this ARG Parse. The first one is going to be template. Oh, sorry, double click. Yeah, the first one is going to be template. I'm going to say, hey, you use my script like Python, my script.py, and then you put // template, and then you put the name of the template file, the Jinja template file that I'm going to use. Then for the inventory, you go like -- inventory, and then you put the name of that inventory file. It can be whatever file we want. It could be a CSV, it can be a JSON, or it can be an XML. And then here we are going to be specifying the format. If it is, here you can see that we're using these choices. Choices will limit the possible values that we can populate here. It can be CSV, JSON, XML, or auto, right? Well, I'm spicing things up here a little bit. If we add auto, we should be able to identify automatically which format we're talking about, CSV, JSON, or XML, right? And then the last one is the output directory. This one is optional. It's like, hey, all your templates that are going to be rendered, where are we going to be putting them at? Okay. So then what about when we choose auto? I'm going to be using this very simple, very small function, easy peasy. I will take the name of the file and I will check. I will turn it into lowercase first. All that name, it will go into low caps. And then I will check if it ends with CSV, JSON, or XML. And I am returning those values. And then I am going to be moving forward with the logic of my script. Okay. So now how to parse this contents, like how to get from this or this to the actual values to get like this name and this IP and this, it will change depending on the format. If it's, again, CSV, JSON, or XML, it will change a lot. So let me show you very quickly how does it work. With JSON, it is very, very simple to do. We have the JSON library, and if we do json.load, it will automatically create a dictionary of this. A dictionary in Python, we will see it later in detail, but let me just tell you, a dictionary in Python, it's a special variable, like a special data structure, in which we have the exact same logic as in a JSON. Key, value, key, value, key, value, key, value. So if we use this json.load, we're going to have that exact same functionality already in our Python script, which is, it's for you to be aware of, that's how JSON load works. We take the JSON, it parses it a little bit, and then it gives us a Python dictionary, and we can start working with the values within that Python dictionary, okay? Now, unfortunately, with XML, it's a little bit more complex than that. We need a specific library, and I prepared here. I hope you understand this. I hope that it's as clear as possible. It took me a little bit to figure out how to visually explain the processing of XML structures in Python, but I consider that it's very important for you to be aware of all of this. So we have our XML file, okay? We are going to be going towards something that is called the root. The root is the main, are the main tags that surround everything else in the file, which in the case of our inventory, that is going to be this tag here. You see, they have inventory. This one swallows everything else. So that is our root, right? That is where we want to get started with inventory. So we are going to be detecting with this function, parse, we're going to be detecting the root of this XML. And then we start going down. Like everything inside of this root is called a child. So the immediate child after the root, which is inventory, is the first device, which would be this one here, right? Would be this one here, this one here. This is our first child, okay? So we have it here. And then within the first child, we're going to get the children of this child, which are all the different elements nested inside. So you see that we're going like from macro to micro, we're getting like deep inside until we get all the information that we want. And then we transform this into this, right? You can check later the logic in Python to do that, but I just want you to be aware of these transformations that are happening, right? That we're going from this root into this children, and then inside of the children, okay? So this is like the 3-layered approach that we're taking here with Python, and I want you to fully understand what is going on here. On the interest of time, because today I had some technical difficulties joining, I won't go into the logic of this script. I would invite you to check it later. It's very well documented here on the repository. However, what I am going to show you is, at the end of the day, what's the user experience with these different formats. So for that, let me open here my console. Okay, let me clear this. Let me go into our folder, which would be the session 1. Then it would be the 4th lecture. Sorry, before that, let me activate my virtual environment. You remember the virtual environments, right, that we used on the last session. So I'm going to do source.bmf bin activate. Okay, now we have our virtual environment. Let me make this a little bit bigger, perhaps. There we go. That's better. Cool. Now let me go to the 4th and final session, and then let's do, I have here my renderer. Okie dokie. For example, this one. We are running the renderer. We're specifying that the template is the Jinja file that we did on the last session. It is on the other folder. Then the inventory is this inventory.json, okay? And then the output there, it's going to be a folder called render. This is a brand new folder. It doesn't exist yet. You can see here, so that I'm not cheating, right? So I will take this, I will put it here, and there we go. You see that here we created the rendered folder, and here we have all our templates rendered. You can see that here. All the information from here is now in this nice configuration files. Easy as that. I didn't have to specify which file extension it is. The script detected it immediately. So for example, if I did let me go back here. My inventory, that would be instead of JSON, if I do XML, there we go. We get the exact same results, exact same files, exact same everything, okay? So this is a very basic example, but my intention here is for you to be aware that the JSON format and the XML format exist, and that many things in life use broadly these two data formats. Okay, so I'm gonna give it a pause here for a second. And now this is a moment when I ask you if you have any questions, you have any doubts. Does this make sense? Does this ring the bell? This is the moment to speak. I'm watching you here in the chat. I'm watching you here on the participants list. Please let me know. Is it good? All right. Thank you, Ismael. Thank you, Clarison. Let me take some coffee. Brilliant. Now, I want to share with you something else just to wrap it up, like this whole lesson. Let me close this. Let me close this and close this as well. In case you've got some spare time, there is a bit of homework for you. If you go to the repository and navigate to the homework folder, you will find here a README file. And it's basically an invitation for you to go back to the contents of this first session, have a look at everything that we did so far, and put it to practice. I want you to set up your own environment, and I want you to take the opportunity to follow this example and do your own exercises. If you don't have an environment of your own, I would like to share with you what I have deployed here in my computer, in my own laptop. If you go here to this file called Poncho's environment and you open it, you'll find the things that I use on a daily basis. What I do for a living is completely dependent on this list of tools and platforms and whatnot. You see here that I use like Python, I use Git and GitHub, I use Visual Studio Code. I have some very cool extensions installed. And here I guide you through the process of installing all of this. You can see that I have here in my Visual Studio Code, I have some extensions so that you can visualize Python, you can do auto-completion, you can do your Jupyter notebooks, which is something we're not covering on this course, but it's very, very useful tool to use. In case you have a Copilot, I show you here how to install it. And well, depending on your OS, if it's Windows, if it's Mac, if it's Linux, here you have very, very brief instructions. I really encourage you to have a look at this. If you don't have an environment of your own, ping me, send me a message on LinkedIn whatsoever in case you run into any issue, and I will be more than happy to help you out. Having said that, let me go to the homework. I'm not going to go into detail for the interest of time. However, let me show you very briefly how it works. So it's basically replicating the same exercise of creating your golden template, something much more smaller. And I would like you, first of all, to create on GitHub, your personal GitHub, your own repository. Let me show you how that's done in case you're not familiar with it in 3 minutes or less. Just let me here log into GitHub. Okay. Now, can you see my browser? If somebody can tell me on the chat or give me a thumbs up if you can see my browser right now. I'm logged in on GitHub. Cool, thank you. This is my secondary GitHub account. So now I'm putting on your shoes. What you're going to do is to create a new repository. This repository is going to be public, right? I can put here code is the new CLI demo, homework, whatever. There's some format recommendations on the exercise. You will make it public, and then you will create that repository. This is your repository, not mine. This is yours. Then here you're going to clone it in your computer. You're going to do the coding exercises. You're going to put here all the evidences, and then you're going to share it with me so that I can have a look at it. How are you going to do that? Very simple thing to do. Okay, so first of all, you are going to go to the main repository. Let me show you here. No. Here, there's all the information, all the instructions. Okay. Oh, I don't have it here. Cool. Doesn't matter. Let me go. Code is the new CLI. There we go. Okay. You're gonna go to the main repository. This one here, where we have all the content. You will fork this repository. What does a fork mean? So it's it's the same word as like the forks that we use for food. It's basically you create your own version, detached version of somebody else's project. Like normally this is how collaborations in open source work. Like you want to collaborate on a repository, you fork that repository, you bring it into your own Git, you do your changes, and then you merge it back with a pull request. I'm going to show you exactly what does that mean. So go here, you fork. Then it's like, hey, create a new fork. Now this is going to pass into your profile, GitHub profile. You do yes, create fork. Okay. So now this repository is mine. Okay, this is my repository, my own version of the repository. What I will do next, if you follow the instructions from Visual Studio, from the homework file, you will create a new branch. You can do, from this point onwards, you can do everything here on the web browser. We're going to go here to view all branches. Then we will do new branch. There's even like a suggested format here, if I'm not mistaken. Yeah, you're for creating this new branch named. I will take this suggestion. We go back here. And then, I don't know, I'm going to put here Alfsando Cisco. Cool. Create a new branch. Perfect. Now, in this new branch, if I go back here, in this new branch, I change it here. I will go to session 1 foundations, homework. I'm here on the folder, and then I will do add file, create new file. And then I think we have a suggestion here. Just give me a second. Let me get rid of this annoying thing. Okay, sorry. Yeah, this one. Submission, and then my name.md. Okay. Then I'm gonna do here Alfsando Cisco.md. And then here I put the contents of the homework, which is this. Show you. Here I do, hey, my username, link to my own repo where I have the activity. What did you use in the end? And please tell me with, like hand in heart, what was the most difficult thing about this if you take up on the challenge? You commit into this branch, commit changes. And then what you're going to do is the following. You go back here, you compare and pull request. And you will do this. You remember when we did the pull requests in the last session. We're going to do the exact same thing, but this is from your fork into my main repository. You can see it here that we're jumping in between personas. There's a suggestion here for the PR. You can use this title, for example. And I don't know, it can be submission from Alfsando. And you can see here that when I create it, there is one file change, right? Which is the file that I created. This is the only delta, the only difference in between your version and my version, okay? And then I later on will check it. I will give you a thumbs up. I will be grateful forever that you took the time to go through this homework. And I will approve the PR so that your evidence goes into the main repository. And that's it. In a nutshell, what do you think? Questions, suggestions? Does it make sense? Don't worry too much about it right now. It is documented there on the homework file. So does it look good, more or less? I hope so. But well, cool. Thank you, Ismael. Without further ado, let's go back into our content because now it is when things start to get real. Oh, Julie, I shared it on the last session. I sent an email today, but let me share it with you right here, right now. Just a second. I have it here on my other screen. Just give me one moment. I will share it with you right now. Well, I'll put it here in the chat. Okay. So there we go. That is our repo. Okay. Now let's crank up the volume to the maximum right now. We are about to get real with interaction with our devices using Python and CLI. So just to put things in perspective, what we've done so far still relies heavily on us getting into the CLI terminals of each and every one of these devices and pushing the configurations that were rendered using the main template that we created with Jinja and all that other stuff. However, what if we wanted to do this automatically using Python, or in some other occasion, like check if things went well, not by going into each and every one of the routers and checking the configurations and spending like, hey, oh, we missed this router. Oh, we missed this switch. This is why routing protocol is not lifting up. Okay, what if we could do that automatically using very simple, very comprehensive Python scripts? There are a couple of options out there for doing this. There are some Python libraries that actually allow you to speak to devices via SSH, via Telnet, whatever that may be. Today, we're going to be focusing on one that I personally find very, very interesting, very complete. And it's not just because I'm part of Cisco. This one is called pyATS. This is a framework. This is a library/framework. It was created internally by Cisco for leveraging test automation inside of our engineering teams. However, it's been a while since somebody said like, hey, why don't we release this for free? Why don't we create this under an open ecosystem license and release it to the public? And that's what they did. So now we can use this Python library for our own projects free of charge, and we can actually contribute to make it better. We can submit requests and all that stuff. So what we're going to do here is to use pyATS to talk to our devices via SSH and to talk specifically CLI. We're still relying on CLI, yes. However, we're going to do it with Python so that you never, ever in your lives have to open an SSH window, an SSH terminal ever again. From this point onwards, that's going to be forbidden. You get a slap on the wrist if you do it. I'm joking, but ideally that's what we want to do, okay? So pyATS, that's our tool of choice today. We are going to be using some real devices actually for testing today. And the best thing about this is that you can use them as well entirely for free. Within Cisco, within the DevNet organization that I'm part of, we have something called the Always On Sandbox Labs. Let me show you what I'm talking about. Yeah, here. Okay. So these are environments that you can spin up for free. You just need to have a Cisco account. I think you can even use your GitHub or your Google account. And well, you can see that we have different technologies here. We have different virtual devices that you can spin up that you can actually use. And it's very cool because you don't need to create virtual labs. You don't need to have like actual equipment to learn, to run experiments, to understand how things work. You can rely entirely on this free of charge. And there's a lot of options here for you to use. The one that we will be using this time, though, it's called Cisco Modeling Labs. This one, when you book it, it will give you, let me show you the one that I have running right now. Just for you to know like what's experience. Oh, no, it's not here. Sorry, because I have here another environment. So let me show you. Yeah, this is nice. When you book it, you are going to get some instructions. Like you can see here, hey, this is a Cisco Modeling Lab. It has a topology, a complete topology inside. You can see it here. Let me zoom in a little bit, maybe. Cool. This topology is yours for you. It's yours for you to break. It's yours for you to configure. It's yours for you to destroy. You can do whatever you want. Completely isolated environment. You connect to it using a dynamic VPN connectivity. You get credentials when you book one of these sandbox labs. You need to download a VPN client. In my case, I am using AnyConnect VPN. But then what you do is that you put here your information, your address, your username, your password, and then you're ready to go. Like all these networks, all these devices, all of a sudden, they are reachable. That's pretty cool because I don't need to be hosting my own virtual environment, sorry, my own virtual network here on my computer, make it blow up. And these are devices with a very similar behavior to what you will find in production. You have configurations, you have statuses, you have routing protocols, you have everything you need to get started with learning and experimenting. So all the information is here in our repository. This is the one that we're going to be using for now, okay? I have it already running. I'm plugged into it already. Let's get it done. Now, second thing, we will use a different virtual environment. On this one, we will have pyATS. You can see here that this is pyATS. All the other things, don't care about them too much right now. This is pyATS, what we're looking for. Cool. I already installed it. Just let me switch there. Let me deactivate the one that I have right now. This is for session 1. So now I want to go to session 2 and activate my virtual environment. Source VM bin activate. Cool. Okay, we're ready to go. Now, let me hide this for a bit and talk to you about something very important. pyATS works based on a topology file. Before using pyATS to talk to devices, it needs to know which are the devices that it can access to and how to talk to these devices. And we specified that by having a file called inventory, well, whatever file, right? Tested inventory, whatever, .yaml. And now you may be wondering, what on earth is YAML? YAML is yet another markup language. As you can see here, YAML stands for YAML ain't markup language. Now, yet another, sorry, this is wrong. It's yet another markup language. This is like a very nerd joke. You will find this. This is like JSON or XML. This is like a data format. This is a way to describe things. You will find it a lot, especially for the people here, the attendees that have experience with infrastructure. If you've worked with like Docker Compose, like your Kubernetes, if you work with things like this, it is all entirely based on YAML. But well, don't worry too much about it. It's super simple to understand. You can see here that it's all about indentation. Indentation are those tabs that we have here. And these tabs define how things are being nested inside of each other. For example, here, I have this main level called devices. I think it's better if I show it to you here, my file, inventory.yaml. We have the main level called devices. Inside of devices, we have different devices. We have 1, 2, 3, 4. These 4 devices are the ones that we have here in our in our topology from the sandbox. These 4 devices, 1, 2, 3, 4. These devices are IaC devices. So I need to specify that here. For example, R1. R1 OS IaC. Type router. Platform IOL. And then the credentials. Which are the credentials that pyATS will use to talk to this device? Well, the default credentials are Cisco and Cisco, very secure, of course. And then the connections. We can have many different connection protocols. Here we only have CLI, but we could have some other things, right? Netconf, RESTconf, we'll talk about those later. And here we have a protocol telnet, and then the IP address that we will use. How do I know all these different parameters? How do I know how to populate this on the YAML file? Don't worry about it. This is documented in the pyATS website, okay? If you go here, just let me show you. Well, yeah. This is the main website, and here you have everything you need to get started. That YAML file, all the different things that you can do, everything is here. This is Cisco documentation, pretty handy. Let's go back here. Okay, I have my inventory. I want to do something with these devices. Cool, okay. Let's go and run a very simple script. It's gonna be called state collection. What we will do here is to run a series of CLI commands and get the results. In this case, I'm going to be running 2 commands. Show IP interface brief, show IP route summary. Easy peasy, CLI, we know about these 2 commands. Classic stuff, okay? What do we need to do for pyATS to run these 2 bad boys in our devices? First of all, we need to load that testbed. We will be using this function called loader.load, and then we put here the name of our YAML file. What will happen is that pyATS will load this in memory, and now every time that we want to refer to a specific device within this inventory, pyATS will know what to do. We'll know which protocol to speak, in this case telnet. We'll know which credentials to use, the one that we put on the YAML, and we'll know some very specific things about the platform. This library is well trained on many different vendor types. iOS, iOS XR, iOS XE, some other third-party vendors, Juniper, Arista, Fortinet, whatever. It knows how the CLI looks. It knows how the prompt looks, and it knows how to mimic the writing of commands as if pyATS was a human. So in the eyes of the device, pyATS is you and me, but in reality, it's a robot. It's a script written in Python. So I'm going to show you what we're going to do now. We will go through all the devices within the inventory, within the YAML file that are already loaded in memory. And then we will send the command. So you can see here this function called collect state. And then here I am doing a very simple thing. Well, 2 things. Connect. I am connecting to the device. Okay, I am opening this telnet connection. I am logging everything that happens because I want you to see what is happening behind the curtains. But if this is false, we don't see anything. And then, super simple, execute. I will send each and every one of the commands, the 2 commands, I'll send them one by one, and I execute them right on the spot. And you will see what happens. It's pretty interesting. Let me go here and clear this up and go to 01 pyATS read write, and then we're going to do python state collector.py. Okay, let's see what happens. I'm gonna stop here for a second. You can see that pyATS is doing a lot of things by itself. It plugged into the device, like this is actual output from telnet. Okay. It logged in by itself. You can see that here. Okay, it's hiding the password. This is a prompt. This is like if you and me were there on a telnet typing stuff. You can see here that it went into enable mode, right? Then it went into the term length 0. It went into the BTIs. It went into, here we have like the banner. You can see here, it did the BTI configuration, and then it started to shoot the commands. and it got the output. Then it shoot the other command. It got the output. And that's it. These are my clean outputs. These are my clean prints. Now I know which are my interfaces. Now I know what's the summary of my routes, right? You can see in the interaction that the device doesn't really notice who is behind the connection. For what it's worth, the device doesn't care, right? This is Python, but the device thinks that it's you and me. That's the magic of pyATS because it mimics this interaction very, very well. And it works flawlessly with many different CLI-based platforms, not only the Cisco ones. So this is pretty cool. Let me show you something else. So let's go back here. I'm going to stop now and ask you, what do you think? If you have ever seen anything like this, if you find it useful, if it's clear, what do you think? If you have any questions as well, let's sip some coffee. Is it good so far? Okay, I'll take that silence as a yes. Now, if the device requires authentication, yeah, this is why we are using the credentials here. Like all these devices, they have a basic authentication. They have username and password. So in the inventory, we specify these credentials for each and every one of the devices. I can tell you that if there's something much more complex, like, I don't know, we have like AAA, we have TACAX, we have something like that, we have a jump host. There are ways to set that up in this YAML definition. That's a little bit more advanced, but it is possible. And it is all there documented in the pyATS website. So if that's your case, you can have a look there, okay? All right. Now, yeah, cool. We got CLI. You know, at this point, we have the exact same result as if we had logged into the CLI terminal, spit the command, copy it, and paste it, like Control-C, Control-V. We have the exact same result. What if, for example, we are planning something different? Maybe we are planning the firmware migration of the devices in our inventory. And we want to check, like automated with Python, with AI, whatever. We want to check which of these thousand devices need to be migrated from this version to the other one. Imagine, you know, like, you've seen those outputs? Those are pretty nasty outputs. You get like this long of like CLI outputs like this. It's not practical to have it to have Python give it to you like this, right? You will need to then further parse this information to work with it and get some intelligence out of it. Of course, you can use some filters, you can use some regex, you can use TextFSM. I don't like it. I don't think that anybody here likes that as well. Like, it's really complicated to do. Even when you have your Copilot, your AI assistant, you will get it wrong the first times, and it's not reliable because these CLI outputs, they change in between versions, right? It's not the same on an iOS XR than on an iOS XE. It's not the same even within the iOS XE from one version to the next. These formats change sometimes. So what I'm saying is, I don't want this raw CLI. I don't want it. It's useless for me. What if we could actually natively transform it into something that Python understands and that we can work better with? So luckily, there's a tool called Genie within pyATS. This is a collection of parsers made with Python that you can use to transform these well-known CLI outputs into actual Python structures. And it's pretty cool. This is open source, meaning that there's more and more collaborations every day. And let me show you, how does that look? No, this is not the one that I wanted to show you. Okay, let me show you what I'm talking about with an example. I'll show you something else later. Let's go here to the parse. This is another script. So you can see here that we have the exact same, this is the exact same command, right? This is the exact same thing, okay? But now here, instead of execute, we're doing parse, okay? Instead of doing device.execute show IP interfaces brief, I'm doing device.parse show IP interfaces brief. What's happening here? pyATS will use Genie. pyATS already knows the device type, the platform type, meaning that it already knows how does this output is going to look like. It knows in which column are the interfaces names. It knows in which column are the IP interfaces. It knows in which column where, of all these things, where is what. It already knows that. So it's going to use a parser for that, and it will give us a nice Python structure that we will see in a moment. Okay. Now, just to make it a little bit more fancy, a little bit more elegant, I am using this cool library. I recommend you to use it. It's called TQDM. TQDM, it's a library to show loading bars so that you can see that something is filling up while you wait, because these things take a little bit, right? So it's for our user not to get desperate, like saying, hey, nothing's working. It's stuck already. Well, no, take care. I'm going to show you the progress in a progress bar. Super easy to use. You can check it here. It's just adding it here in your for loop, and it works nicely. I'm going to show you how it looks in a moment. So let's get to it, and let's do Python state collector parse.py. And I'm going to put this here. Okay, you can see there that it is thinking, it is getting stuff. Here's the first device. You can see here how that loading bar it's appearing, right? And then voila, instead of having this ugly CLI raw output, we have a nice, here it's in JSON format, yes, but we can use this better on Python, right? Here we have our interfaces. Each interface element has a name. This name, within it has an IP address, it has an interface is okay, it has a method, it has a status, it has a protocol. It's way easier to work with this than with that. And I hope that you agree, okay? Unfortunately, this doesn't work for all the commands that are out there in the wild, okay? Especially for those commands that are a little bit more obscure, that are a little bit more like niche, it will likely not work. And let me show you an example. Well, before that, there is a list, an official list of commands that are supported. For example, the official catalog. You can filter, let me zoom in a little bit more. Here you can query based on the platform. You can see here the iOS, iOS 60, iOS XR, the NSOX, ASA, the classics for Cisco, but we also have other vendors. I mean, Linux, we have Juniper, here we have Viptela, DNAC, we have a couple of things here. And here you can see which are the commands that are supported. So for example, if I want to look like for interface of iOS 60, interface. Sorry, show IP interface. There you go. You have to put the CLI command. I forgot about it. Like show IP interface brief if supported, show IP interface brief / include villain is supported, and so on and so on and so on. But what if, for example, I use I query for here / exclude unassigned, it won't work. So then what I recommend you to do in those cases is to do a try except. So it's like, hey, I'm going to try to parse it. It's going to give me an error, right? If it's not supported. We're using the error type parser not found. And then I will tell you that something went wrong. And then I will give you in the end the raw output, right? You won't live here empty-handed. So that's basically it for the parsers. I'm going to stop here for a second and ask you, how does it look? Does it make sense? Do you have any questions? Do you have any doubts? What do you think so far? Like, is this connecting? Are you discovering something new? Thank you, Lawrence. All right. So far, we just did read-only things, but we can also write stuff. We can also commit things into our devices. pyATS is not only for retrieving and parsing configurations. So let me show you a script that we will use for creating a loopback interface in case it is not there. Let me show you here. I have a script. It is remediator. Yeah. Okay. Let me minimize. So our show command is going to be show IP interface brief, the one that we know and love. Our remediation, the configuration that we ideally want to have there is this loopback interface. Loopback 100 with this IP and mask, and then no shutdown, right? Ideally, we want to have this in our devices. So let me show you how this works. Let me collapse all of this. We are going to check a drift. We're going to check of all our devices if they have or they lack this interface. First of all, we do that. We are going to be collecting the interfaces, right? We do the parse CMD. We are parsing the show IP interface brief, right? We get that. Then what do we do next? We check the interfaces, right? And we get the interfaces. And then if loopback 100 is not in those interfaces, what we are going to do is to create that interface, right? What we're going to do is to configure those interfaces. You can see here in this configure that I am sending different CLI commands at the same time. We can do that as well with pyATS. We put them here in a list and we send them all at once, and then we see what happens. So without further ado, let's clean this up here and run this this script remediation. I think with this one I have arg parse. No, I don't. Okay, it's fine. You will see what happens in a moment. Okay, we're connecting to our devices. Here I deactivated the logging, so you don't see there the logging. So then here you can see that for our device, what happens is that we check the interfaces, then we're like, hey, loopback is not there in the in the interfaces, okay? No, it's missing or it doesn't have the IP address. So it's this IP address. It is not there. You can see here that it's 102, and then here it is 103, right? So now we applied this, and then if I run this a second time, let me just get rid of this. Okay, it's gonna do the whole checks again. Let's wait for it. Let's wait for it. Okay. And there you go. Now we have loopback 100, and it has the right IP address. Okay. So you can see now that pyATS, we use it not only for retrieving things, but then we're also using it to apply things as well. We can commit configurations using pyATS. Okay. So far, so good. Any questions, any doubts? Looks intimidating at first. Yes, I agree, but it's much more simple than you think. It just takes getting used to it a little bit, and you can do a lot of things with it. Even if you are vibe coding, if you're asking your favorite AI assistant, I strongly recommend you to ask it to use a pyATS approach, because it's guaranteed to be robust, scalable, and now you actually understand what's going on behind the curtains, right? And I want to remark that this is just the tip of the iceberg. There's so much more within pyATS that you can leverage, but this is just, for you to be aware of how it works, right? What you can do on a basic level with it, okay? All right. Speaking of those, going beyond the tip of the iceberg, there's one final feature that I want to share with you about pyATS. Go here. Now, we have this saying, a picture tells more than 1,000 words. With pyATS, we can do something very similar to taking a picture of our devices. It's like taking a snapshot. A snapshot would be a more appropriate term for it. We can have a before and then after. So let's say that we are preparing for a maintenance window. We're doing the setup of a new branch in our routers. So we can go to each of these routers and take a picture, take a snapshot, and we have those as a backup, as evidence, okay? Then the big night of the maintaining windows comes, We have our engineers deploying changes, whatever. And then after those changes are done, once the maintenance window happens, we take pictures, we take snapshots of the same devices. Everything with pyATS. And then pyATS allows us to compare picture A with picture B, like the before and after. And we actually can tell what changed in between the before and the after. There's no need to do, like this drift checks that we did before. pyATS can do that automatically. And it's something very interesting. Let me show you how it works. Like the taking of pictures of snapshots. And right, so we're ready on our virtual environment. Let me show you how this works very briefly on this script. So basically, what we are going to do is, I want to show you something first. We are using something called learn. This function, device.learn, what it does is that it tells pyATS to send a specific list of commands to our devices. These are collections of commands that are already inside of pyATS. Those are embedded inside of pyATS, and you can actually check how does this work. Like if you go here to this documentation, let me show you very quickly. Here, in case you're curious about what you can do, you can take these snapshots of these different features, ACLs, BGP, ARGP, like a couple of routing protocols, platform, when you're migrating between platforms, route policies, interfaces are here, of course, right? And then you can check what's the model, the configuration, the operation, all of this is written in Python. So what we do is that we using this .learn command and then indicating what we want to learn, like which is the kind of picture that we want to take. We take one before, we take one after, and then we can compare what happened in between. Okay, so this is like a matter of like evidence when we are about to run a maintenance window, whatever that may be. So for this, I'm gonna give you for free a couple more interesting tips for pyATS. What we have done so far is that we go device number 1, device number 2, device number 3, device number 4. That takes a lot of time. Right now it's just 4 devices. Imagine 1,000 devices, right? It just doesn't scale up. Like your script is going to be there running forever. What we can do, we have 2 options. The first one is to use Python multiprocessing. There's a huge debate about this, like if Python can really do multi-threading, if it doesn't. It's a kind of worm, so I'm not going to go into there right now. But there are techniques basically for asking Python to run things in parallel, meaning it could be checking device number 1 at the same time as device number 2, at the same time as device number 3, all in parallel. So you don't have to wait all this long, like this one to finish, then I go to this one, then I go to this one, okay? We can use Python multiprocessing, Python multithreading, or we can use an included tool within pyATS called pcall, which stands for parallel call, which basically allows us to specify a set of devices, and then we're just going to go with it and say, hey, run this function, in this case, the one to take the snapshots, at the same time, for all of these devices, which is our 4 devices, in the hopes that it will make the time more efficient, okay? So I'm not going to go here into detail. The code is there, super well explained, if you want to have a look at it. But well, this is what we're going to use from this point onwards to make it much more faster, okay? So having said that, let's go and take our pictures. What I'm going to do here is to execute the file snapshots.py. So snapshots.py. This one I already put some ARG parse. Sorry. Let me go here to the other session. Cool. Now, yeah. Python, my bad. Sorry. Sticky fingers today. And there we go. Okay. We are going to use snapshots.py to take a pre-snapshot, a post-snapshot, and then to report the differences. So let's do that. I'm gonna do how was it? I forgot. Pre-snapshot. free snapshot. There we go. Okay, what's going to happen now? So that like, okay, we got device 1, 2, 3, 4 at the same time. Right now, pyATS is connecting to each and every one of these files at the same time, and it's sending a series of commands, right? Taking the picture of the current status of the interfaces. That is what's happening right now. It will take a little bit, but then we will have those snapshots in place. Okay, there we go. This is the before. This is JSON format. Now we know how to speak JSON. Lucky us. So let's go here, snapshots, and here. I want you to understand that this has a lot of information. This outputs, right? Yes, we have the interface name, the description, the type, opera status. We have much more things than what we would normally get with a show IP interface brief. You know that this command gives us 4 or 5 things max. No, what happens is that pyATS, when we take a picture of the interface's status, it throws a series of commands. It throws what is it? An IP status. It throws the protocol checks. It throws lots of things that have to do with interfaces, and then it cross-references all that information for each and every one of these interfaces. So we have the MTUs. We have somewhere here. Yeah, we have the IPv4 information, the counters for the traffic, the packages that have passed through here, the rates, encapsulation, all that stuff is here. And then for the other one, and the other one, and the other one, right? This is the big picture, so to say, of everything that is happening with our interfaces, which is pretty cool, right? And again, how this works is documented in the link that I shared with you before, right? And this now it's for interfaces, but you can take pictures of BGP, pictures of platform, pictures of many, many different things that are supported within pyATS. Okay, and enough about the pictures. Now I want to make changes so that you can see the before and after. So now I will run the command apply configs. So that will be Python. No, here. I just remember. No, it is apply configs. Yes, sorry. Apply configs. Okay, cool. We're gonna create the new interface, loopback 400 in each of the devices at the same time. We save some time here. Okay. And 1, 2, 3, 4. It's all good. Now we're closing the connection. Just wait a little bit. Yeah, we're good. Okay. Now the 4 devices have a delta. Now they have something different from the first picture against the second picture. Let's find out. What we will do here is to do snapshots post snapshot. Okay. We wait for these snapshots to be taken. Okay. Okay. So far, so good, folks. Is this making sense? Are you excited to be what's going to happen next here? Okay. Nice. We have now the after pictures, the post snapshots. So we go here, and you can see we have before, after, right? Let's just check this one randomly. The new interface is there. Loopback 400. So now let's do the final thing here. If you remember, this script had 3 options each, which was pre-snapshot, post-snapshot, and report diff. We're going to go with the report diff. So that's going to be report diff. Okay. Sorry. This one has at the same time options that we need to populate. You can see it here. You see how argparse is super handy, that it tells me, oh, no, you're screwing it up. You need to put here some more options. We're going to do the following. Before file, that's going to be from our folder snapshots, it's going to be R1 before.json. And then we're going to do after file, it will be snapshots R1 after JSON. And then the output file, we don't care. You can see here that we have some outputs, but I want to show it to you on the file. No. Okay, because I didn't ask it to write the file, it will show it here. But I don't want to see it here. I'm gonna do output file r1 underscore diff dot log. There we go. It saved it to r1 diff dot log. Let's find out what happened here. Let me collapse this. You can see here that, I mean, yes, for some of the interfaces, there are some counters that changed. So we have like, before it was like this. Every time that you see a minus, that's the before state. Every time you see a plus, that is the new state. So if we scroll all the way to the loopback for 100 interface, you see that everything is a plus because the whole interface is brand new. And this, you will have a similar experience like the minus for before, the plus for new, if you compare the snapshots of before and after of all these other configurations that are supported by pyATS. Okay? Sorry, I saw that we have a question here from Franco. Would you also do an example of routing protocols like BGP and MPLS? How to configure the same in device like Cisco router using the automation? Unfortunately, I won't do that today because we still have a couple more topics to cover and we are running short on time. However, definitely BGP is supported. MPLS, I'm really not certain, but it just takes you to check in the official catalog if these snapshots are supported. I've seen BGP live as part of some projects, and you definitely get those deltas. Like when you create like a new route or something, you're going to see it there. Okay. MPLS, I think MPLS is not supported. You wouldn't be able to do that. Okay. But yeah, BGP, it is here for sure. Okay. Yeah, sorry that I can't showcase it right now, but we need to cover other stuff. This is for you to get the big picture of how this works with pyATS, and you can actually do this pretty much automatically. So having said that, folks, this is the moment when I shut up for a little bit and ask you, does it make sense? Do you have any doubts? Do you have any questions? Is it clear for all of you? Yes? No? Okay, I think that we're good then. So now with the time that we have left, I want to share with you something very different. And for this, I want you to toss away everything that we've done so far regarding Python. This is the moment when we switch gears and we talk about something different, which is infrastructure as code. What we have seen so far relies entirely on support of CLI and a very tight customization. We are basically creating tools that are tailor-made for our specific needs. So what happens if we don't need that level of specificity, right? We don't need to be that specific about what we want to do with our networks. If we want something more general for some basic housekeeping, for any basic net operations that we do on a day-to-day basis. And also, furthermore, what happens if I want to use Git, not only for my templates, my CLI templates and my Python tools and scripts, but also to store the intended state of the configurations within my different network devices. That meaning I want to be able to version on my Git the state, the configurations, the statuses that my devices should eventually have in my different environments. There are platforms that allow us to do that with different approaches, right? We have a different approach depending on what platform we're talking about. So now I want to give you like a very, very brief one-on-one regarding Ansible for networking. With Ansible, what we're doing is pretty much describing the tasks required for us to have intended state in our network devices. And we do that using a series of elements, a series of files that we need to run on a specific order. We need to set up and run in a specific order, right? In a nutshell, what we are going to have is, let me show you. First of all, we will be using, where do I have it? First of all, we will be using what we call modules. These modules are ready-made entities, they're ready-made collections that know how to interact with our devices. You know, the same way as pyATS knows how to talk CLI, via SSH, via Telnet, via other protocols with our devices. We have modules normally created either by developers or by vendors themselves that know how to talk to the different devices, right? In the case of Cisco, Cisco has published many different modules that can be used for interacting with Cisco devices of different platforms, different types, what so on, right? Whatever. So we're going to be using these modules. In this case, we will use the modules for Cisco IaC, so we can interact with this kind of devices. Now, we have, I talked about the modules. We have two other key components here. We start with an inventory, which is a pretty similar idea to what we have with pyATS. An inventory is going to be basically our list of devices and also all the different details associated to those, like what's going to be your protocol, what's going to be your connectivity type, what's going to be your credentials, username and password, and so on and so on. And then the core essence here is our playbooks. Where playbooks are basically these lists of tasks that we are going to let Ansible do so that we can achieve this intended state in our different devices. And I will mention it in more detail later, but right now here, there's a keyword that I want you to put in your minds, which is idempotence. Idempotence means that no matter how many times I apply something on my device, I will always get the exact same result once it is applied on the first time, right? So it's if I set up an interface on a device and then I run the exact same playbook 1,000 times on that device, I'm going to get the exact same result. It may sound weird at the beginning, it might sound trivial, but this is very, very important. It's a very important thing to understand. Because Ansible allows us to do that, to proactively know if a change is needed or not. If it is not needed, it will simply not move forward. That is the basic principle of idempotence. If there's nothing to change, I have nothing to do here, so I do nothing. Okay, we'll put it into practice later, but you know, here from straight off the bat, I want you to have it. I want you to picture it in your minds, okay? Because this is very important. Now, which lab we're going to be using? We will use a different sandbox, always on sandbox. This is the IaC one. This one is pretty peculiar because it is a shared environment. What does it mean? You are highly encouraged not to mess up greatly, right? Like this one operates on the principles of good faith of the users, if I must say. Sorry. You need to book it. And once you book it, you don't get a VPN credentials as we did with the other sandbox. What you get is a username and password that are onboarded inside of the device, so you can use them for connecting into the device, right? And now the device is yours for the period of time that you booked it. And here you have the information, you have some credentials, you have here, like for example, it's the hostname is XRD1. And all that stuff, right? So I already did it, and I already have my set of credentials. Now we're going to change virtual environments. I already did that. We are going to install our collections. The collections are, imagine it like, well, I mentioned it before, this is where the modules come from. We get them from this catalog called Ansible Galaxy. It's like we checked the last session, right? The PyP, that it's like this huge library of Python libraries where we get them from using pip. Well, Ansible has its own version, which is called Ansible Galaxy. From here, we download everything that we will need, which in this case will be the ones of Cisco IaC. So if we go to the file here, collections requirements, the YAML, we are using two collections that we get. It's like if it was our Python libraries, the exact same idea. This one we needed. This one is a dependency of this one, right? So this one is like basic network connectivity. This one needs to actually talk to iOS XR devices. And this one is published by Cisco. First thing we do, I already did it because it takes some time, right? So we install those collections with this command. Cool. Okay. Now, what happens next? We are going to be putting together the inventory. Very similar idea to what we did with pyATS. Here we have our inventory. Yeah. And you have here, so we have a group called iOS XR. Inside of inside of iOS XR, we're going to have what we call hosts, one or many different hosts. Our host is going to be only one, the X31 device. And then this is going to be the IP address or host name that we're going to use. Okay, that's cool. But now, you remember that in pyATS, in the same file, the same YAML file, this is also YAML, by the way, the same YAML file, we put the credentials. Here, we're going to put them somewhere different. And this is a very good practice. We're going to put them in a folder called group bars, and then here on this file called iosxr.yaml, okay? This should be secret because we're putting this on Git. So this should be secret. These are my credentials. I don't want my credentials out there on the internet, right? That's how security breaches are done. And then, companies appear in the news for the worst reasons possible. So a good practice is to have here like the template. And then when you're going to populate it with your own credentials, what you do is that you copy the file, you remove the .example, and then here you put the actual credentials that you will get from the sandbox. Okay, so this is what I did already. So recap, device details here, device credentials here. Okay, easy peasy. Now, let me close all of this and let's move forward a little bit. And okay, how do I know which variables to use, right? You saw here network OS, collection, Ansible user, password, right? These variables, they come from the documentation of iOS XR. Like I didn't come up with them randomly. The exact names of these variables, they will come from this documentation. You can see here on Ansible Galaxy, I have the documentation of this module, Cisco iOS XR. I go here, it will let me know how to use all the different options that I have. Okay, cool. So let me close this and let's run. We're almost top of the hour, so I'm gonna explain to you how to retrieve information. Right now, we're just gonna do a read-only operation. I'm gonna get some specific information, some specific commands. That's it. Okay. So we have our playbooks folder here, our playbooks. We have 3 playbooks here. I'm gonna use the first one. On this playbook, let me zoom in. This is YAML as well. Don't get confused. This is YAML format as well. We have here some metadata. I'm telling Ansible, hey, this is the name of this playbook. The hosts, you're gonna get them, iOS XR. This is the name that we have here in my inventory. iOS XR here, iOS XR there. So now Ansible knows where to pick it up, okay? Then collections, we're gonna use the module of Cisco iOS XR, the one that I showed you before. Cool. 2 tasks, and 2 only for now. The first one, I named it, hey, just run these show commands, please, whatever. What we're going to use is this functionality of the module, Cisco iOS XR command. Input arguments, the commands, 2 commands, show version, show IPv4 interface brief, okay? Whatever you get from here, you're gonna put it in this variable, so to say, which is iOS XR underscore show. This could be whatever, right? This is like a variable in Python, could be whatever name. When you do register, you're telling Ansible, hey, whatever you get here, you put it here. Because then what I'm going to do is to print in the screen whatever you put here. That is the second task here. Whatever you got, just print it, right? Like this is like some built-in stuff from Ansible. Now, how do I know how this works? Well, we go back again into the documentation. We have here, or you ask your favorite LLM. I hope it gets it right. But it's more than often, it's great to know where things come from in case your LLM hallucinates. Here you go. You have the documentation. You go to, in this case, I'm using IaC command. And it's telling you, hey, this one is to send arbitrary commands to IaC node. Okay, this is just for arbitrary commands. Cool. Okay, I can work with that. So without further ado, let's run our playbook. Let me open my terminal. Where is my terminal? Just give me 1 second. Okay, it disappeared. Let me bring a terminal here. It's actually here. Yeah. Cool. Okay. Let me go back to this session. Ansible basics. And let me copy the command very quickly. I should have it here. Okay, this is how we run our playbooks. We go and say Ansible playbook, playbooks one read state dot. Well, this is the name of my playbook, right? Read state.yml. Let's see what happens now. Wait a little bit. It is connecting to the device using the credentials provided, all that stuff. Okay. And then you can see here that it ran the task, okay, the first task of the show run commands. And then it is printing the results of the two commands. This is my like show IP state, and this is my IP interface brief, okay? Easy peasy, read only, right? It's pretty much the same thing as if I used my pyATS, my CLI, whatever, okay? This is just read-only for you to know how it works. Now, what I can do is to crank it up a little bit. Let's crank up the volume and actually do some changes in my device. We're almost top of the hour, so I will go through this very, very quickly, and maybe we can go deeper into detail in the next session next week. Now, I am going to use this other playbook called configure loopback. So we'll go here, the playbooks, configure loopback. I am using the exact same collection, Cisco IOSXR. Here I declare some variables, same as we do in Python, right? Like the variables that we use. But here I am defining them like this. This is how you define variables in a playbook. So we have a loopback name, loopback description, loopback IPv4. Cool. Now the tasks that we're going to do, we have here a couple of tasks. The first one, we are going to be using this specific functionality of the module called IOSXR interfaces. This one allows us to check if this interface is there already, okay? If it is not there, it will try to create it. When we use this state merged, that means that if it is there and it matches this and this and this, which is name, description, and enabled, leave it untouched. Principle number 1 of idempotence, okay? If it is not there at all, create it from scratch with this and this and this, name, description, enabled, okay? And then if it is there, but something doesn't match, either the name or the description or the enabling status, change whatever may be missing. That is the state merged functionality. Whatever happens, save the result in this variable, okay? Then something very funny happens with this module, because when we are talking about interfaces, we can configure some very specific things, like a name, description, enabled. If we want to do like IP addresses configurations, we need to use another different functionality called L3 interfaces. It kind of makes sense though, because this is interfaces in general, but IP addresses and such, that's layer 3 of OC model, right? So sorry, I wanted to show you. Ansible does that. This module does that division very, very specific. So if you go here to the documentation, it will tell you like, hey, if you want to do, let me zoom out a little bit. If you want to do like interfaces like description, MTUs, speed, you use this one. If you want to do IP addresses and such, you use this other one, right? And you have here like all the different parameters, IPv6, all the stuff is here, right? So, well, it is what it is. It is what it is. We have to split it in half. Same principles. If the if the address is, if the interface is there with this specific IPv4, you do nothing. You don't touch it. But if there's something that needs to be changed or created from scratch, you do something. You create it from scratch, okay? Or you update it. And then here, this is just a print, right? I am printing the results of these other two tasks. And then here, I am using the module that I used before, the one of the arbitrary commands. Just, let's show running config, this specific interface, just to see what happened, okay? And then the result, I just print it. That's it. We're almost top of the hour. I will run this very quickly. It won't take long. So what I'm going to do is playbooks to configure loopback. Okay. Okay. Give me 1 second. Sometimes it happens with this device that the first attempt doesn't go well, but then the second one goes forward. I think it's the situation with the sandbox. Now it's looking good. Let's just wait a couple of seconds. Okay. Changed. If there was nothing, it would read, okay, let me go back. You can see that the first task of creating the interface attributes, that was name description enabled. Idempotence, if there was nothing to change, you shouldn't change anything. But this interface didn't exist. So you are changing something. Then the IPv4 address, if there was nothing to change, you don't change anything. But this was brand new. So yes, you're changing something. And then here we're just checking the, that something changed, just to output. And then here we're running our show IP interface brief, and we can see that the configurations are right there. Like that loopback interface is there live, okay? So now Ansible gives you the summary. Out of all the things, there were 2 things that I needed to change because they were not there before. So now what happens if I run this again? The exact same playbook. It's going to check this, right? It's going to check if the interface is there. We wait a little bit, Nothing changed. Before it was yellow, now it is green. And also for the IPv4 address of the interface, nothing changed. So we can see here, changed 0. Okay? This is the principle of idempotence that I talked about before. And well, now you can see it in action and how important it is. So I'm going to stop talking right now. Let me stop sharing my screen. And we already passed for 1 minute, but if somebody has any question, if somebody wants to raise their hand, I can unmute you. If you want to put your question in the chat, this is the moment. The microphone is all yours. So what do you think? Or in general, what do you think? Did you learn something new? Did you find it interesting? Please let me know. What do you think about this? Whatever that may be. Yeah, Ismail, about the recordings, a couple of people have already asked me about it. Lawrence and myself would check later after the crash course, which will be the best way to share them with you, with all the attendees. But yeah, rest assured, you're going to get these recordings one way or another. Any other question, folks? Did you find it interesting? Did you find it useful, perhaps? Oh yeah, I will just slide on the next one because we didn't have a lot of time today, so I need to pack things up. And I also was a little bit late with the issue that I had with WebEx. So, right, no, thank you, Franco. Thank you for being here. Thank you, Clarison. Thank you, everybody. And we'll have a great weekend ahead. Enjoy and see you next Monday. Bye-bye. Oh, sorry. Before dropping, Vic, practice more. There is homework in the repository. I will explore it on detail on the next session. And getting Sandbox Premium. Yeah, unfortunately, yeah, you cannot get Sandbox Premium. But but it's the exact same experience. All the collections there, all the resources are there for you for free. You just need to get your Cisco account. Some of them have a limit of bookings. So if you want to book something, but it's already grayed out, that means that there's a lot of users using it in that specific moment. So you just like go back a couple moments later, try your chances, and you will spot it for free, I'm sure. Okay. Well, we're already on top of the hour. Once again, thank you, guys. I really enjoyed your company here. Have a great weekend and talk to you soon. Bye-bye.